Okay, I've got this DeWalt charger here. It's a model DW9116, very popular charger. The problem I've got with it is I was charging a battery, came back. Normally when the battery's charged, you'll get a light here that stays on. Nothing. Completely dead. So I unplugged it, took the battery out, tried a different battery, I plugged it back in, tried a different battery, nothing. Completely dead. So I was taking a look at this here, and there are 4 screws on the bottom. They are, I believe, like a Torx security bit. I just dug through a whole bunch of bits that I had until I found one that fit, but they're the ones that need the little hole in the center, and then there's one here. So I decided to take the charger apart and start troubleshooting it, and I did, and I'll show you the process I went through. Okay, here's the board out of the charger. If you can take a look, over here's where the 3 terminals are that plug onto the battery. That's where you put the battery in, it makes contact with those. And upon looking at this board here, I'll show you the steps that I went through for troubleshooting it. And I'll do that right now with you. Okay, so the first thing I did was I noticed there's a fuse on the board right here. So I did a continuity check on the fuse with my multimeter, and the result was the fuse was open. Okay, so I could change the fuse, and according to the internet, yeah, that seems to be a very common fix. Seems to be one of the very only fixes. That and a bunch of people that just haven't figured it out. At least from what I saw, I didn't look too much. So I decided, well, let's just kind of double check the board, because there may be a reason why that fuse blew, but it may have just fatigued. There is quite a bit of inrush current when you plug it in. So what I did was I decided to see, well, next step would be this here. So I looked up to see what this was, and there's a number on the chip, and I looked it up, and it appears to be an N-channel MOSFET. So looking at the data sheet, it says, okay, great, now I've got the pin out. So what I did is I put my meter on the legs. I just did it in circuit to make sure that it was not shorted, and I'll do that right now. Okay, so I've got the meter connected, and what I did was I went on the across the source and drain. The gate is what actually drives this, so I just went across the source and the drain, which is basically your in and out. That's what's switched. The circuit, there's a circuit on here that puts voltage to the gate, and that switches the source and drain on and off. So I'll put the meter on ohms and hold it up a little bit so you can see, and I'm getting not a short. It's about, we'll say, 250, 260 kiloohms, and it appears that, because you're reading the rest of the circuit as well, it appears the ohm meter is charging a capacitor. That's why the reading keeps going up. So we're definitely not shorted. I mean, I guess I could try this, just reversing the polarity. Okay. And we are still definitely not shorted. So that's a good thing. So then I disconnect everything, and it helps to have these little clips. It definitely helps out a lot. You could actually do it without. It's kind of a pain. It's kind of a pain anyway. It's really not the easiest to get to these pins. So that's usually a common point of failure on a lot of circuits. The next thing I noticed, okay, there your power comes in. There's a little transformer here. And there's a whole bunch of diodes on the board. Okay, well, that's an easy thing to check. So again, you take your meter, okay, you put it on the diode mode, and we are in the diode mode now. And basically you would just go across, and you may have to test these out of circuit. You may be able to do them in. I was successful in confirming the good ones in circuit. Okay, so I've got nothing. That's good. Now if I reverse it, reverse the polarity, which I'm going to do on the meter because it's easier. Just reverse the 2 leads of the meter, and that's my reading. Okay, so the diode appears to be good. And I did that on every diode on the board I checked, and I got similar results. You know, approximately the same number in one direction, in the other direction it was open. So then I continued on. Well, actually, no, I found two bad ones. These two here that I lifted up with a solder, it was unsoldered one side, these two were shorted in both directions, dead short. So I says, okay, let's make sure that it's the diodes themselves. So I just simply heated up the back of the circuit board and gently, with a real small screwdriver, applied light pressure, and I just lifted the one side. Now the diode can be tested out of circuit to make sure that the diode is bad and that it's not something else in the circuit causing the diode to look bad. So we're on our diode mode now, and I'm going to go across the diode. Ooh, that's not good. Ooh, that's not good at all. Now I'm just going to reverse the leads. And it's probably going to do the same thing. Ooh, that is not good at all. So, these two diodes are shorted, and I've determined that through the continuity check that the top three diodes go across one side of the AC plug, and the bottom three diodes go across the opposite pole on the AC plug, which I think is very interesting. The other thing I noted was the diodes that are bad are the only diodes with the stripe, with the white stripe on this side. The other diodes all have the white stripe on that side. So, I don't know, it's possible there's some signal transistors. It's going to be nearly impossible to check every one of those because the ends I have are like this. I may have some smaller ends somewhere else, but it's a possibility the diodes just went, but it's also a possibility something else could have taken the diodes out. So in my junk box I found some diodes that I'm going to try to replace them with. They're used diodes I pulled off other failed boards, but they tested good. And I checked with the data sheet these diodes, which are 1N4006. You could use a 1N4007. It's the same diode, except for the 4007 is a higher voltage, which is fine. Higher voltage is good. You don't want to go lower. These are a slightly higher voltage in all respects on the data sheet and a little bit higher current. So these diodes will work fine. And if I blow them up, I really don't care. So I'm going to try to replace the diodes. Hopefully they won't blow again. And we'll see if that fixes the problem. These circuits can be kind of a pain to check. The other thing I did take note of, and you really can't check capacitors in circuit, but I'm sure there's devices out there that will let you. I don't have anything that'll let me check it in circuit. These are not bulged. So that's good. Not bulged, not leaking. There's a lot of glue around everywhere. So they don't appear to be bad, although that doesn't necessarily mean they're not. Although the charger was working fine. It was charging the battery fine. And then all of a sudden, it wasn't. I walked away for 5 minutes. I came back. Charger was not working. And I had already used it prior to that day to partially top a battery to finish a job I was doing. So, we're going to try to change these diodes and see what happens. Okay, we got the old diodes removed. Made sure that the holes in the board are opened up and not blocked with solder. We're going to install the new diodes. And pre-bent them. Just make sure that you install the new ones in the same exact orientation as the old ones. It is labeled on the board, so that black stripe is where the white stripe goes, but you definitely want to confirm, because I have once in a great while seen where the stamping on the board is incorrect. So whatever way the old ones came out, make sure you put the new ones in. So it's just a matter of popping them in there and soldering up the back. And I'm going to do that right now. Okay, diode's in. Little trick, just kind of hold the diode in, or any component, and just take the leads that are poking through and just slightly bend them to the side, and that'll help hold them in while you flip it upside down and solder it. You don't have to bend them much, just enough so that when you turn it upside down to solder it through, that they don't fall out. Okay, all done. Should probably, I would recommend taking some isopropyl alcohol and where you made the solder to repair, clean the solder off the board, or the flux off the board when you're done, because the flux can not only be conductive but in some cases can be corrosive. So I'm going to test it first, and if this works, I'm going to go ahead and clean the flux off the board. But before I plug it in, usually I just use a little magnifier. I like to just make sure that my solder joints are good quality solder joints. It should be shiny. It should have adhered to the pad. I just like to double check that. And just double check that, and we're going to hopefully put power to it. Solder joints look good. Diodes double checked facing the right way. Just go ahead and trim the excess lead length. And we're all set, hopefully. We'll find out in a second. Okay, we're ready to put power to the circuit. Now remember, the fuse is still blown, and I don't have a fuse with ends. I'm going to have to get that because that's soldered onto the board. They got the leads coming out, but you don't want to just jump the fuse out, because in this particular circuit, if you do that and there's a short, this transformer will instantly get hot, start smoking, burn out, and it could start a fire. And if anything else is shorted, that could overheat, and it's never ever ever a good idea to use a switch mode power supply without a fuse, ever. So we've got our fuse over here, and I just got it clamped on. Now keep in mind, this is line voltage, so you do this at your own risk. You can potentially electrocute yourself if you come into contact with any of this. So obviously I'm going to be careful here, but you do this at your own risk. I'm not recommending you do this. So I'm going to plug in the charger, and one of two things is going to happen. It'll work, or it'll blow the fuse again. So let's see if we've got that fixed. Oh, did you see that? There is an inrush. That's what the snap you heard. That was the inrush charging capacitor. Now let's see if it... Oh, look at that. So what this is telling us is that it appears right now that nothing... I'm going to plug it back in. It appears that nothing else was wrong. The diode just decided, I'm done. Okay, now you want to make sure you plug this in correctly. We're going to try to plug a battery in and see what happens. Now you want to make sure you plug it in with the correct polarity. Now looking at the charger's case, there are 3 terminals. You can line up the 3 terminals, but also, if you look at the charger's case and the way it plugs in, the short side of the battery goes towards the LED. So we're going to, and there's very high voltage here, so I would highly recommend putting it back together before you do this. I'm not, but just because I do it does not mean it's a good idea. And actually, I'm going to unplug it first, just in case. Okay. Of course, it is not going to want to stand up. This is probably not a good idea, but that's why I'm doing it. It's something to shove under there. Well, I guess I'm just going to have to hold it. So, we'll plug it in, and we'll see what happens. Will you look at that? It is charging the battery. Look at that. We just fixed the charger. I'll be darned. Okay, well that's good news. So we apparently had fixed the charger. I'm going to unplug this. I'm going to remove the battery. Now you have to be very careful still not to touch anything, because these capacitors can remain charged for a while. So you definitely want to make sure that there's no power on those capacitors. They should bleed down themselves, but that doesn't mean DeWalt put a circuit in there that does that. So you can usually discharge those through a high value resistor, something in the kilo ohms range, and just make sure check with your meter, or let the darn thing sit for a couple days. Usually the leakage will bleed them down. And we're ready to address this fuse problem. So right now I'm going to unsolder this fuse, and we're going to figure out what we're going to do with that. Okay, so I unsoldered the old fuse, and it came apart as I was doing so, and dumped sand all over the place. Great. So it was a T2A, which there really isn't much information out there on this fuse online, although I did find somebody on Amazon that had a fuse 5-pack for sale that claimed it would replace 4 different sizes, one of them being the T2, or T2H rather, was what it was. And they claimed that they would replace that. So what they were giving for the specs on that fuse was it's a 2 amp slow blow. Well, I have a 2 amp fast blow, and you can replace a fast blow with a slow blow, or a slow blow with a fast blow. All that means is the fast blow may not be able to handle the surge. So this is the fuse I used to test with. And I didn't have one with wires coming off of it, so what I had done is just soldered wires onto the ends. This fuse is a little longer. It looks like it'll just barely fit in the case, but if not, I can tip it this way and allow that little bit to allow it to clear. It's a little taller. This is a fast blow, so it may fatigue over time. I may have to get the right one. However, you never want to replace a quick blow with a slow blow. But the important part that this fuse does is, in the event, obviously the diodes had shorted, but in the event anything would short, it would prevent you from starting a fire. It's not necessarily there to save the circuit, although I suppose it could. So we're going to put this back together and see if it will work. But before I do that, I'm just going to plug it in one more time. Just confirm. Oh, and it still does work. Did you see that? Okay, I think we're in business, so we're just going to put it together. With that, it fits. I'll be darned. Run some screws in and we'll try it out.